next week since it's on Thursday.
On Thanksgiving?
Yeah.
I asked Mr. Hess over email. She said that we're going to combine both meetings on Tuesday, but I don't know if that means that we're going to do a 4-hour meeting or it's going to be condensed or I don't know what.
Yeah, I'm gonna be in Alaska, so I don't know like how much I'll be able to do. I'll do my best though with time zones because
Well,
it
you've
would
got a
be.
test then as well, apparently.
We have a test next week as well.
According to the
Apparently.
schedule, we have a test next week, no test the next week, test the next week, no test the next week, and then the final. One test on,
So,
one test off until the end of the semester.
but why would she do that to us on like a week break?
I don't know. I don't think. I'm
I
guessing because
think this is just like the standard.
yeah,
That
I'm guessing it's because since Pathway and BOU Idaho split, we're like guinea pigs. This is the test run where they have to do it by themselves. So I'm guessing that's why there's a lot of errors. But
There should still be like holiday time.
for real, on campus that Thursday and Friday are off. So I don't know.
On campus, Wednesday, Thursday, Friday are off, right? Wednesday through Friday. Is that what she said?
Oh, I don't know. I don't know. At least Thursday and Friday
Okay.
are.
Wednesday, Thursday, Friday, you have off.
Yes, I don't see how they could possibly think to have a test that day, but I don't know. We'll see. She'll have an announcement in the next few days.
It's online. They don't care. It's like a honey badger.
Honey badger don't care.
I bet you don't care.
Number 2, it says the following problem guides you through answering the question. Quote: find an equivalent algebraic expression for. Close quote. Discuss each part and make sure you understand the process and can answer the questions. In your book, you will find a different process, but we introduce you how this type of problem is solved answered in calculus. Dun, dun, dun. Question. Find an equivalent algebraic expression for sine of tan inverse of x. For the question given, what are we looking for? Question mark. In your book, you will find a different process, but we introduce you to how calculus answers this type of question. That was a little bit redundant. Given that x is a side length, the output of tan inverse of x is an blank. Given that x is it's an angle. Would you say that's fair, guys?
Yeah.
I think that's fair. It's an angle, I guess. That's all I can think to say. Now,
Well, if you're finding the inverse of a side, it'll always give you an angle, right?
Yeah.
So I'm assuming you're right.
Angle.
But wait, for an inverse tangent of x, you would need another coordinate, wouldn't you? It would never just be inverse tangent of x. It'd be like inverse tangent of x divided by something else or multiplied by something else. No, never multiply, just divide it.
It's asking about, well, what is the output of this? What are we trying to get? What does this equation give you?
An angel, I guess.
That's what I thought too when I saw it. It says
I don't know what else you could find. Maybe, well,
I don't know.
Never mind.
I like how the next part says find the third side, but we were never given a second side.
Well, maybe tan negative x gives you another side. Since you have
Sine and
makes
cosine.
sense. If it gave you a second side, then maybe it would give you. Then you have two sides to find the third one.
Who knows? Nobody knows.
Well, what's the? Because isn't there? Well, there's no inverses, so I guess that doesn't matter.
Well, this is all hypothetical anyway because there's no numbers to begin with. I guess I could
let me.
Someone's got the timer going.
No, it's just the snooze button.
Oh, that works too.
When you guys called me to chat, I was in the bathroom. I didn't bring my laptop in there.
That was probably me. I thought I'd do the text anyway.
That was you. Okay, let me save your number.
So we were right here. It says, I've got a thing. It says the arctan function is the inverse of the tangent function. It returns the angle whose tangent is a given number. So it does give us an angle. And then it basically is just saying, yeah. So I guess we're right on that one. Just to know we're on the right track.
And labeling each part.
Oh, so now find the third side. So we could just use, what is that? Adjacent over opposite, opposite over adjacent. And that would give us the third side.
Well, no, if this is a right triangle, to get the third side, we would just do sine squared plus cosine squared.
Yeah, honestly.
True that.
Equals h squared. Yes. Hypotenuse. Is this all just hypothetical? I don't see any numbers.
Well, we have x.
True. Oh yeah, got an apple.
It's a sweet roll.
Oh, a sweet roll. I thought it was an apple.
Nothing warms me up to breakfast like a sweet roll.
You now find sine of theta. Sine of theta equals what? Oh, sine of theta equals opposite over hypotenuse.
Sorry if you guys can hear my chewing.
Is that really what we write there?
I don't know. It doesn't seem right to me because now it's like, oh, now you have the equivalent expression. So I'm.
We were never given a first expression.
Well, the first expression is sine times tangent, arctangent of x. So really, oh, actually, I guess that is right because if you do sine of an angle, because we know that the arctangent of x of a side equals an angle. So really, you're just doing sine of angle equals. So you're just trying to find the angle, right?
Yes.
That makes sense. So that would be the opposite thing because the inverse tangent's just helping you find an angle.
So the equivalent algebraic expression then would be what?
It'd just be your sine theta equals your opposite over hypotenuse.
Wow, that was easy.
Because that finds your angle in the corner.
Good grief.
I would assume, but wouldn't that just find you the 90-degree angle?
The opposite of the hypotenuse? I don't think so.
What angle would that find? So if it's opposite, that'd be your cosine over hypotenuse, right?
Oh yeah, right.
And so wouldn't that find the 90-degree, or would that find the angle in between those two?
I would find this angle right here.
Okay. Then we're good, I guess.
Oh, yeah. I was doing this a little list before. Where's Jerem when you need him? Factor the following trigonometric expressions.
What the?
Okay, so this is pretty simple. We know this since this is minus. When you do a minus b, it's a plus b times a minus b kind of thing. So I just
when you put cosine 2, did you mean to put cosine squared?
yes, I did. That's simple enough. And then I was applying the rule that says cosine squared plus sine squared is equal to 1. There I go. I came up with this result. Hmm. I can't do something about this one.
Is that cosine alpha times tangent of alpha minus 2 cosine alpha
Cosine
minus
alpha
3?
minus 3 tangent of alpha. Yep.
So the only thing that we factor is cosine squared alpha tangent alpha.
Couldn't we pull a tangent out because you have two tangents? So wouldn't it just be, if you pull the tangent out, wouldn't it just be tangent x of cosine x? So you'd also pull an x out, so it'd be, well,
we'd be missing a 3, and one of the tangents is multiplied and one of them is subtracted.
well, yeah, but when you FOIL it out, you can FOIL it out. So I'm wondering if you could just pull out tangent. Well, because they all have alpha, right? So could you pull out a tangent alpha, and that would just make it tangent alpha times cosine. Oh, I don't know if you can pull out an alpha, actually. Because what you'd have for your two numbers is you'd have -3 and +1 in order to get your two numbers. I know that. So when you FOIL it out, it would work out that way. So I know our two numbers are -3 and +1, but I don't know how to pull anything out of it.
Hmm. Could we factor by regrouping?
Or could we substitute?
I don't know.
Just suddenly make tangent x stand for, or tangent alpha stand like bx.
Oh, wait, no, because you have cosine squared. If we just pull a tangent out, then you just have cosine alpha -3 cosine alpha +1. Because if you just pull the tangent out, because that's the thing that's throwing it off. Otherwise, so if you look at it and you pull your tangents out, it leaves you with cosine squared alpha -2 times cosine alpha -3, right? So let me see if I can't write it out. It's making sense in my brain, but I'm not sure if I'm making sense out loud. So if we pull a tangent, I'm just going to swap it out with x because I don't know how to do alpha, just so you guys know. Squared. Two. Pull this out. And then if we simplify that, it would just be, well, actually, you can simplify that to be cosine x minus 3 cosine x plus 1.
Oh no, we've got it backwards. So in the equation, so I'm looking at the answer sheet right now. Sorry guys, but we're not even reading the problem correctly because it's not labeled correctly. It's supposed to be cosine squared alpha times tangent alpha minus 2 times cosine alpha minus 3 times tangent alpha.
Yeah, this is what I did. I just pulled out, because I didn't know how to do alpha, so I pulled out the tangent x, well, tangent alpha, and then I had left was the cosine squared x minus 2 times the cosine x minus 3. And then if you FOIL this out, you get the cosine x minus 3 times cosine x plus 1. Because this times this would get you your squared x. And then negative 3 plus 1 would get you your negative 2. And then you'd also get your negative 3 by multiplying that out. And then you'd get your cosine x. So all you gotta do is FOIL this back out.
Was it
Does
right
that make sense?
there?
No.
So normally if you'd FOIL, so if we just take this equation here, and you FOIL it, you do first, then inner, and then outer, and then last, right?
Mm-hmm.
And so you'd have cosine square, oh, sorry. If you did your first, you'd have cosine squared x, be this one times this one. And then you do your inner, which would be, let me do this. And you do your inner, which is negative 3 times cosine x. So you do minus 3 cosine x. And then you do this times this, which would just be negative 3.
Well, hey Chris, have you looked at the answer sheet yet?
No, I was trying to figure out what it was.
So I'm looking at it right now,
What does it say?
and we've got it. Like that's the answer.
So what is the problem supposed to be?
It all you're doing is taking out tangent, and then it's cosine x minus 3 times cosine x plus 1. But I don't know where the plus 1 is.
Well, it's when you reverse FOIL it out, because one thing Jerem said, that he said your two numbers have to add up in order to get the middle number, and then they multiply in order to get the outer number. And so if you add those two up, then you get your middle number, and then if you multiply them, you'll get your outer number when you essentially reverse FOIL.
Oh, that makes sense. That makes sense.
So all I did was pull the tangent out, and then you just have to reverse FOIL it.
That makes sense.
Did you hit snooze or did you hit stop? I hit stop last time too. How many alarms do you have set?
A ghost alarm. Okay, we'll move down to the last one, which is the type of problems that I hate the most. Using the identities you have learned from the different strategies to verify the following identities. It's suggested that you spend about 5 minutes considering them individually, then work together to do the verification. This will give you the opportunity to formulate a plan on your own before being influenced by your team members' thoughts.
I like the influence.
I do too.
I don't know what I'm doing without influence.
For real though.
No, I guess we can stop sharing. Oops.
I feel like this is like one of those problems that you did back in algebra when you had to derive the quadratic formula.
Oh my.
Which
I don't know what algebra you were doing. I never know how to do that stuff.
Sanity. Then it was on the test. Anywho.
So just so you know, that first one, when it says divided by cosine squared x, it's all, that's under everything, the entire fraction.
Yeah. All this divided by cosine squared x.
Okay, sweet. We also didn't get the triangle one right.
Oh, what was the triangle one?
We got angle right. Angle's correct.
Good.
What did we get wrong?
The rest of it. So it says we begin by, okay, so there's the angle, and this says we begin by drawing a right triangle labeling each part. And then it's, whoa, that's weird. It says squared x, or x squared plus 1 equals unknown squared, which is c squared. Then c equals square root of x squared plus 1.
X squared. Freaking A, man. X squared plus 1 squared.
Just x squared plus 1 is equal to c squared.
Okay.
And now it says now you can find the sine of x, which is finding the third side, which would be plus or minus x over square root of x squared plus 1.
Square root of x squared plus 1.
Yeah, weird, right?
I'll say.
I'll repeat it.
But that's right, though. That looks good.
Yeah, and then you say the equivalent algebraic expression of sine x is equal to plus or minus x over square root of x squared plus 1.
The equivalent.
Which is the last part of the question.
Oh, that's what this is?
Yeah.
So what's this supposed to be?
The same thing.
Okay, so just get that right.
Sine of theta or sine of x is that.
What? The
same thing.
Weird equation?
Yeah, which no one knows how she got.
Who knows? Okay, so what are we going to do about this? That's the question.
Let me do a little scrolling.
Do we know for sure if these are correct or incorrect, or they're actual identities or not identities?
No, you can find them.
Okay, so we know that for sure they're legitimate identities.
Yes. Which they look so confusing because you always have to remember what each thing does, and I just don't have that memorized yet. Like I do, but I can't do it in 5 minutes.
Yeah, I don't know how to apply it very well. I mean, I've got the list of everything and how it transforms, but even looking at it, I'm still like, okay, great.
I still look up the unit circle.
So we have a, well, it says, well, never mind. I don't know.
So I guess
So we need to get the first equation to equal tangent squared x, right?
Mm-hmm.
Yeah.
Perfect. Yeah, that's how you do it then.
That's the answer. It's given to us. The answer is tangent
right
squared
there.
x.
Yeah, it's right there. All of that will equal tangent squared x somehow. So, well, tangent squared x equals 2 tangent x over 1 minus tangent squared x. But I don't know if we need to do that or not. So we need the right side. Well, I don't know. We need the
Wait,
right
what did you
side.
say? Tangent squared x is equal to what?
There.
What did you just say?
This one. See, tangent 2, well, was it tangent squared x or tangent times 2x?
No, tangent squared x.
Well, that doesn't help at all then. Why are you guys screen sharing that?
Dang, he's mad. He's mad.
Yeah.
So do we have sine squared x plus cosine squared x? Because that equals 1.
No, the answer. So
Well, because we'll have to swap them out, right?
Oh, look at that. Yeah, you're right. We have sine squared x right here.
Do we have plus cosine? Well, how do you times a multiple? So we have cosecant. Can we take a square root out of all that?
no.
I don't think so.
Because we have sine squared, cosecant squared, sine squared divided by cosine squared. So can we just square root the entire thing and get rid of all those, and then we can work with the factors easier?
I guess we could try it. I mean, what's harm in that?
Well,
Well,
you have tangent squared x too, so if you take the square root of all of it, I don't know.
what is cosecant? What is that equal to? I don't even remember anymore.
Cosecant equals 1 over sine x.
1 over sine x.
Yeah.
Well, 1 over sine.
So that's yeah. So 1 over sine angle. So if that's equal to cosecant, we have that squared plus sine squared x. We can cancel those out because that's the inverse of sine plus sine. So we can just cancel that out.
Oh, yeah. That was easy. And then you just have it made right there.
And then you have 1 minus sine squared. And then because there's a plus right there, I would imagine you would keep a plus 1.
Wait, but can you cancel those out? Because you have sine squared times cosecant squared.
Yeah, you can cancel them out. That's what she did.
Okay.
And divided by cosine squared x.
Well, then the answer you would have is 1 minus 1 plus sine squared x. No, you don't cancel that one. You don't cancel the second one out, the plus. You cancel the first one out. The sine 1 minus sine squared x times cosecant squared x. You cancel those two out.
So what he's saying is all that you would have left is 1 plus sine squared x.
Well, no, you'd have 1 plus 1 or 1 minus 1 plus sine squared x over cosine squared x.
Like that?
Which is equal to tan squared x. Because tan is sine over cosine.
Insane.
Okay.
Tell everybody hi for us, James.
Oh, I'm being told that it's too early to be saying hi to people.
Okay. All right. Never mind then.
I'll tell him when we're done.
Okay. Thank you.
My wife was in the room with me, but now she's leaving because I'm mathing loudly.
Yeah, you already woke up.
Apparently, I woke up the guests with my math.
Asking for help.
I did, and you know what they referred me to? Mathway.
Oh my.
They're like, you know what always works for me when I was doing trigonometry? I was like, what? You're like, Mathway.
So great.
All right.
Oh.
So.
For a second there, I said that you woke up your guests with meth, not math. I was like, what?
Cooking meth in the kitchen.
Party house. Okay.
Well, so the answer, so sine squared x over cosine squared x is equal to tangent squared x, because tangent is. So what's just tangent squared x? You have to simplify one more time.
Hold it.
What? Vocal fry. I like it.
Oh yeah, okay. I got it.
You got it?
I guess my question was if that sine x had a square, but it doesn't. So what were you saying?
So the answer, so tangent x squared, or tangent squared x, is equal to. No, I'm talking about in the second one. In the first one. We're not. There's still one more step. The answer is just tan x squared. Is equal to tan squared x. Sorry, it's the same thing.
Yeah.
Because sine over cosine is tangent, but it's squared, so tangent is squared.
Oh yeah, that's what I said that, but then I guess we could be more formal and do that.
Yeah. Well, that's just what she has. It makes me feel better when I don't know how to do it. I just copy her.
It's usually the safe route to go. I don't know how to do that, so I'll just copy the instructor.
And for this one,
I know the answer, but I don't know how do they get it, and I don't want to cheat. Do you guys want to know the answer?
not yet.
Not yet. Let's just see if we can figure it out.
Equals 1 over tangent x sine of x. X actually.
What? Isn't cotangent equal to cosine over sine x?
What?
Oh, right. Sine over cosine, right.
You're right, tangent is, cotangent is cosine over sine.
You're right.
Is that right?
Yeah, that's right.
Okay.
Because it's the inverse of tangent.
Yeah. So it's cosine over sine times sine minus cosine. Boy, this is looking great. I have trouble with math when I don't understand when I would ever need to use it. It's hard for me to wrap my mind around why am I doing this?
Hey Chris, why did you put it over 1? Or why did you put it under 1, I guess? You said 1 divided cosine.
Oh right, not that. You're right.
It would just be cosine divided by sine.
Yeah. And that's just one. That's because that's secant. The only time you'll ever use this math is when you're teaching your son or daughter who is also in pre-calculus. That's the only time you'll ever use this.
If my children are gonna be this invested into math, I'm gonna like make sure they know what the heck they're doing.
Okay. Hopefully this makes more sense. This is what a math teacher told me to do. When this doesn't make sense, convert it all into sines and cosines. See if that gets you somewhere. Okay, so that makes sense.
Yeah,
We can
we're
get
just
rid
trying
of
to
the
get
sine
this to
x.
equal 0, right? So I'm assuming this entire side will all cancel each other out.
That's what I
Because
presume.
if you take the cotangent that we just swapped over, you can get rid of the one of the cosines, and you can get rid of the can you get rid of the sine x?
No, because it's 1 over sine x.
Oh, because you changed it to cosecant or secant.
Yeah, I changed from secant to sine.
But secant equals 1 over cosine A.
Really? I thought it was the other way around.
Well, I've just got this list here. If you guys, I don't know if you guys want to see the list or not, but
It
it's the one
works.
she gave us. So
Works for me.
Wait, secant is 1 over cosine, right?
yeah. So cosine and sine, don't they cancel each other out? Or no? We've made some good progress here, boys.
I feel like this should be something that we see on Thursday, not on a Tuesday.
It's about to be.
My worry is that I'm getting like really lost in all of these, and so I'm getting like I'm hoping this will just like end and I'll never have to see it again. But I know it's not going to happen.
My grade has plummeted in the last like 3 weeks.
It's been horrible. I'm so worried about what my test score is going to come back as because I really struggled on it.
I felt good. Like
Yeah,
I felt good on.
A test
Yeah, the
is so hard.
I felt good except for the first part. Hold on.
Which one? The one that was worth 25 points where you had to convert everything without any help?
Oh,
I feel like I did pretty good on that. It was the rest of it.
Yeah.
But I think I did pretty good on the multiple choice. I hope.
We all do.
well. Well, that's where the minus sign is, so I think this side would be able to cancel out this side. That's what we want to get to.
Sorry guys, my wife is wanting our pancake recipe so she can start.
Do you have a secret pancake recipe?
Yeah, it's the third link when you Google easy pancake recipe.
Oh, nice.
Everyone say hi to Bay.
So
Yeah.
I said it's up.
So,
Ask her if she knows how to solve this problem.
Hey, Taylor, which one are we doing? The third one?
Yeah.
Do you know how to
Well,
solve this
we're
one?
still on the second.
She did. She didn't even look at it. She said no.
the answer.
Just say the answer is 2 tangent squared x.
2 log.
No, we're not even
Fart.
on logs. Fart,
Negative
babe,
3.
get out. What are you doing?
I can log if I think of these.
Hey, you need to leave. All right. I'm
Oh,
back.
oh yeah, oh yeah. Kill him. There's like a function on
What?
Symbol Lab. Kill him.
There's a function on Simple Lab.
Just to do this.
Really?
Yep.
Simple Lab? What is Simple Lab? Is that like a math way?
Symbol Lab. Yeah, it's like math way. Kill
Simba? Simbo Lab.
Simbo Lab. SimboLab.com.
Oh, I'm gonna bookmark this.
They also have an iPhone app as well. I didn't say that though.
Yeah, there is, yes.
Did he just say it and then say that he didn't say it?
You didn't hear that from anybody.
What did I say?
You didn't say nothing.
Who's talking? It's funny because like we can't see Taylor, and so like whenever he speaks, it's just like an angel coming out of nowhere, like giving us guidance.
A voice from the dust.
There's an app on iPhone. See, I always thought that was minus cosine x. It's negative cosine.
Yeah. Well, they just rearranged it.
Oh.
Yeah, it didn't do anything except for rearrange, it looks like, anyway.
And that was it. That just said that equals 0. Done.
Well,
anybody else have any ideas?
How to do which one? The second one?
Yeah.
No, that was it, wasn't it? We just rearranged it. That's the answer, right?
Yeah, I think that was it.
That's it.
Frick yeah, man.
So this 2 tangent x squared. So honestly, like we could work backwards from these ones, so you know that it's going to get down to 2 tangent squared x.
Well, sometimes it can come out as false and things.
Does it all go on the same bowl?
Yeah.
Or do I mix it up separately?
No. Don't forget the chocolate chips.
There's about to be no chocolate chips from nobody.
Ouch.
Dang. Chris is not happy.
Nobody gets chocolate chips. Do you have all your family over for Thanksgiving or something?
No. My wife's brother came to visit with his girlfriend for a week.
Oh,
They got
nice.
here on Saturday. So
Well, that's fun.
yeah, except we had a car for them to use during the day, and then sure, and then we got into a car accident like the day after they came in. So now we only have one car.
Nice.
And it's good luck. Anyways, equals 1 over cosecant x minus 1.
This is true. Whoops.
Oops.
Cosine of x squared
Oh, this is plus.
times 2 equals
I have no idea. I'm seeing what they did. I guess what she did. But I have no idea what I'm doing or how to do it.
I don't either.
Just type it in this piece.
How does that even? Oh. Hmm. So is this true then? Does that work?
Well, this one we're not dealing with cosines and sines. We're dealing with tangents, cosecants, and that's it. But the second to last step is 1 over no, what is it? 2 over cotangent squared x. That's the second to last step.
Sorry, what? Where'd you put that?
What do you mean, where did I put that?
Like on the document. Do you not see the document?
What do you mean on the document?
Where should I put what you just said? Excuse me.
Oh, so like that's the second to last step. So instead of, yeah, so you could leave sine x divided by cosine x. That equals tangent. So 2 tangent x squared. You could leave it like that. You don't have to convert it to sine and cosine.
I guess. Okay.
Is equal to 1 over, or no, I'm sorry, 2 over cotangent squared x.
Okay.
And 2 cotangent squared x is equal to 2 tangent squared x. But I don't know how we got cotangent. I'm just okay.
What the heck was that?
I'm just stretching and changing position.
Oh, that sounded really weird.
You're welcome. Okay.
Let's see. Mhm. Oh,
So the third to last step. Do you want me to tell you what it is?
sure, why not?
Well, if you don't want me to tell you, I don't know how they're doing it.
You
I
go
guess
ahead,
I'm
because I don't
supposed to
either.
doing it. It's cosecant x plus 1 minus cosecant x minus 1
X minus 1. Uh-huh.
all over cosecant squared x minus 1.
What's that supposed to equal?
So do you have the beginning part, cosecant x plus 1 minus cosecant x minus 1?
Yes.
And then, so yeah, cosecant x plus 1 minus cosecant x minus 1 is all over cosecant squared x minus 1.
Say that again. Cosecant x plus 1. And then what?
Cosecant x minus 1.
And that's
No,
all over.
No, yeah, so you had the denominator, right? But the numerator is just the opposite of the first one. So you have cosecant x minus 1 or plus 1, and then you just do minus cosecant x minus 1.
Like that.
Yeah, without the squared. Yeah. Well, the denominator has a square in it.
The denominator does.
Yeah.
There. No, that's not what we wanted. TSC squared x minus 1. Okay.
But how do you
Who is
Sorry, I'm just trying to get a charger. My laptop's about to die.
Okay.
How do you get from Dunga? How do you get from the what's in the red to the third step? Honestly, you could probably delete the sine and cosine ones because that's
Confusing. Honestly.
yeah. How do you get from that step to that step though? Like I can't make sense of that.
Nobody knows.
Well, honestly, I feel bad. I haven't done the prep for this week. But I feel like even me doing the prep for this week wouldn't have prepared me for this.
Mm. Oh. No.
What is cotangent equal to? Cosine over sine?
Yes.
And what is cosecant equal to?
1 over sine.
Cosecant is 1 over sine.
Mm-hmm.
So you have 1 over sine divided by 1 over sine squared.
Oh, that makes sense. Okay, the last one makes sense to me.
Can you explain it to the rest of us?
Yeah. Okay. Whew. Oh yeah, so you have to expand this cosecant out.
Mm-hmm.
So I'll give you 1 minus sine squared x, which is this one,
Mm-hmm.
divided by, if you expand this out, it would be negative, parentheses, negative 1 over sine of x plus 1, which is this. I
Which is
believe.
what?
No. Oh yeah. That'll give you, there's actually a step in here between. Let me put that step, make it less confusing. More organized, I suppose. That quantity divided by negative, oops, negative,
Would you get the plus 1
where?
at the end of the sine x? Negative 1 divided by sine x.
This one?
Yeah.
From there. Oh, wait.
Oh, yep. No, that's right.
Yeah, that's right, that's right, that's right. Always second guessing myself. And then this whole thing simplifies down into this. This one simplifies down to this. We'll simplify to that and then that. Oh, it's super obvious. Look at this. It's so obvious. You can pull this negative and put it right there. So that tells you automatically that this one and this one are equal. And you could do the same to this one. Pull this negative out front, canceling out this one and making that positive.
Then what happens to the 1?
It just cancels itself out. It becomes, oh, I guess that's true.
Who needs ones anyway, right?
Oh, got neutralized down to here. I don't know. It worked out somehow.
All right. Well, that's how we're doing it. Sounds good.
I've got a good feeling about this week's group quiz coming up.
Don't even remind me of that horridness.
I've just like slowly gone downhill in this class. Like at first I was like, yeah, I understand all this, and now I'm like, I got no idea what's going on.
Yeah, and then like the teacher sister has, she's just like cheering us on gladly as like we're plummeting to our death. She's like, good job, guys.
Keep going, you got it.
Finish strong.
Well, I love it after like the last test, not the one we just finished, but like 2 weeks ago. she sent me an email and she's like, "Good job, you're on your way for passing." And I was like, "I got like an F on that test. How am I on my way to passing?"
Sad day.
Just let me.
Yeah, I destroyed one of the tests, like destroyed it in a bad way. Like there was one of them that only had 4 questions and I got one of them right. And that was a multiple choice. And like when that happened, that was like the first really bad grade. I was like, oh geez, here it goes. The beginning of the end right here.
I hate when there's only 4 problems, and you know if you miss one, you're just automatic C. No matter what happens, you got an automatic C for missing one problem.
I wonder if she's gonna drop any of the grades at the end of the grading period.
I doubt it. I hope though. I really, really hope.
Like, what if she's like, all right, I'll drop the lowest tests because there's like 15 of them.
Seriously though. I'll just drop all the tests. That'd be amazing.
Oh my. If a teacher did that, that'd be fantastic. I had one math teacher here on campus though, where if you got like above 4% higher on your next test, he'd raise your last test grade up to 4% under it. So he said he had a student who didn't take any of the tests, and he took the last one, got 100 on it. So that put his third test at 96, his second test at 93, and then his first test at 91. He didn't have to take any of them.
That'd
Except
be
for the last one.
Yeah, I just want to pass.
I know.
Yeah.
All right,
So,
are we done?
Better be.
Okay.
we're never
Sweet.
done. No, just kidding.
All right, guys, and
See y'all
just
on
enjoy
Thursday for another.
enjoy the days in
house.
between. Enjoy Monday, Wednesday, and Friday before you have to do the exam.
No
Oh,
joke.
well.
All right.
Anyways, we'll
See ya.
All right, see you guys.